Hi students, okay, let us see the working of a power supply. Let us start with a very simple power supply where we have a half-wave rectifier. So I have a center tap transformer which is something like this. It is actually 15015. What I have done is I have connected between 15 and 0. Okay, the actual connection made now is this is 230 volt AC signal with 50 hertz frequency, and this is something like this. What you have, this is 15. This is connected to diode, and I have a resistor which is connected like this. So this is what is the connection I have. So for which I'm measuring channel 1 here for input. This channel 2 is over here. So this is what is my waveform on the love discovery. You can see this is my frequency 50 hertz signal, and C2 is average. If you can see, this is a half-wave rectified signal. The output is actually less by input by that diode drop, because the diode is there in between the input and output. Now what I'll do is I'll put a capacitor of around 500 microfarad. So the moment I put the capacitor, so I'll get a pulsating DC whose peak voltage will be V peak minus VD on, and it will have some decay, that is ripple voltage depending on my R value and C value, which is now 1K and 500 microfarad. Let me just do that. So you can see now I'm connecting a capacitor across that resistor. Now this is that you can see now it is charging here. Now this is the discharge. I can actually measure the ripple voltage. What I'll do is I will go to channel 2, and this peak to peak. This is that 1.1 volt ripple voltage from this to this. So from here to here, it's actually 1.1 volt difference. And if you see, the average of your C2 is around 20 volt. That is, this is above. It's almost close to 20 volt. So what I'll do is now I'll apply. Now I will connect a regulator. Let me just come back here. I will connect a 7805 regulator, which is a 5 volt regulator. This is pin number 1, pin number 2 is grounded, and pin number 3 is my 5 volt output voltage. Let me go back here and then see. So I will retain this input to the regulator, and I'll take out this input of my rectifier and see that as the output of my regulator. So channel 1 I'm removing, and the channel 1 I'll give it to the output of regulator. So you can see now this is the output of regulator, which is constant at 5 volt. See, now this is constant 5 volt. If you can actually measure that channel 1 average is almost 5 volt. You can see this is 5 volts. This is what I'm trying to see, the voltage at this is now C2. Now I have connected C1 here, that is channel 1 is here, which is actually 5 volt constant, because the input to this regulator is somewhere around 20 volt with a ripple of 1 volt. So this is what I'm getting. I can actually see the line regulation. What I'll do is I'll remove this capacitor. The moment I remove the capacitor, the input at this point will become a half-wave rectified signal. So in such case, any voltage beyond some 6 volts, it will be get 6 or 7 volts will be get regulated. Below that, it will be almost following the input. You can see now what I'll do is I'll go back to my this one. I'll remove the capacitor. You can see I have removed the capacitor. You can see this is the rectified signal. This is my regulated output. If you can see here, this is the input to the regulator. Let me just go back to my screen parallelly. Let me just give me a minute. Say this. Let me just make this half. Now I have removed the capacitor. The moment I remove the capacitor, I get a rectified signal. So this is without this capacitor. I'll get it like this. This is like this. So there is around 8 volt or 7 volt as per the data sheet is the minimum required. So what happens, the output almost follows the input. It becomes of course it becomes constant at 5 volts, and then it again comes down. So this is the regulated 5 volt. This is a regulated 5 volt. That's what you're seeing here. If you want to see that line regulation graph, so what you can do is let me just again go back here. If you want to see the line regulation, which is nothing but V in and V naught. So this is till around 7 volt. It just goes almost with a slope of less than 1. Then it becomes output voltage becomes 5 volt. So that you can get it by viewing the add xy. Add xy is now it's coming like this. What I'll do is I'll just interchange them. This is C2, this becomes C1. This is perfect because my C1 is output, because C1 should become the output, matlab y axis. This is the input, which is my x axis. This is what you're getting. So this is you can see here it is 5 volt per division. Maybe let me make it 2 volt per division so that you can able to make out. This is 2 volt per division. Make this also 2 volt per division. You can see now this is 2 4 6 6 point. This is 2 4 6 somewhere here. So somewhere here it becomes constant, the input voltage. The output voltage is exactly 5 volt. You can see it is around 5.8 or so. This is constant 5 volts. This line is, you can see this is actually 2 4, this is almost 5 volt. When the input is almost around 6 volts, output becomes 5. So that's what is evident here also. You can see when the input is around 5.8 volt, output is constant 5. Output is constant 5. This is your line regulation. For load regulation, what you can think of doing is, let me just go back here and then show you what happens if you do load regulation. The moment, let me just connect a DRB now. So let me connect a DRB at the load point. I'm trying to connect a DRB. So this is at the load now. Give me a minute. Let me connect that load also, that is capacitor also. Also regulated output voltage. I will cancel between that and ground. Let me go back to my, you can see, let me run this. You can see now, okay, this has been removed. Wait, just a minute. Okay, this has been removed. The connection has came out. Fine. You can see now this is constant 5 volt. Now I have a very large load. What I'm supposed to do now is, for load regulation, I will connect. Okay, this is my 7805. So this is the input, which is a pulsating this one. Okay, now for this I'm having a capacitor as well as the resistor, and of course my rectifier is there as it is. The capacitor is there now in place. I will put a resistor. So the resistor value is initially very high, so that I have a very low current. This is IL versus V0. Ideally speaking is I should get a constant voltage whatever the load is, but actually typically what I'll get is I'll get something like this. The load voltage reduces, sorry, the output voltage reduces as your current increases. So if you can just see here, now let me just take out this. Let me take out this also. Let me just measure the output voltage. Measure C2 average. You just have a look at the C2, this one, C1 average. Okay, let me see the C2 average also. This is my C2. This is C2, which is very high, and you can see C1 average is around 4.99, that is 5 volts. Now let me start reducing the resistance. So while reducing the resistance, now I'm reducing the resistance. You can see it's almost same 5 volt. Now this is, now I'm reducing. You can see now when I'm reducing this, you can see this output voltage okay, let me make this also same volt per division so that you can feel the change. See now the output voltage, this is your output voltage. So if I further reduce output, the load current, load resistance, you can see this 5 volt has reduced to 4.9. This is further reduced to 4.8. This is further reduced to 4.7. What I mean to say is this is now reducing. It was there at 5, now it has 4.9, 4.8, 4.7. So if I further reduce the resistance, it will become, you can see now it is 4.5. So this is what is load regulation is. So actually why this is happening is, why the average voltage is increasing is, why the average voltage is reducing is, it's because the regulator is now got loaded because you're trying to draw more and more current out of it. So that's why even the input has pulled down here. So this is the impact of reduction of RL, which will increase the load current, which will reduce the V0. So this is what is load regulation. Load regulation. Okay, this same thing you can do it for a full wave rectifier, or it can be bridge rectifier. Okay, thank you.